the reference terminal to which the negative probe of the voltmeter is connected, so just ground it to 0 volts. And in each case, we need to figure out what the mode of operation is for the BJT. So to the right here, I brought some figures from the textbook to help us out with this problem. So first I want to point attention to this BJT figure itself. So we have the emitter, the base, and the collector. And we can see the voltage drop here, base to emitter, voltage drop, collector to base. So one way to think of this problem is you can think of two diodes operating in this BJT. So one is going from base to emitter. We call this the EBJ, emitter base junction. The other diode is going from the base to the collector, and we call this the CBJ. So one way to think about it is if the EBJ is a diode, it can be either reverse or forward biased, and that's the same principle with the CBJ. Now I want to make one more note that for the EBJ or the CBJ to be forward biased, then the voltage difference needs to be at least 0.7 volts. So let's start with case 1. So if you look at the EBJ, we see that the base has 0.7 volts, the emitter has 0 volts, so we have a voltage drop of at least 0.7 volts across the diode, so the EBJ is forward biased. Now let's look at the CBJ. The base has 0.7 volts, and the collector also has 0.7 volts. So we have a voltage drop of 0 volts, which is less than 0.7 volts. So the CBJ is going to be reverse biased. And if we refer to the table, we see we have cutoff active saturation. And it looks like, based on our figure, we have a forward biased EBJ and a reverse biased CBJ. So this is going to be in the active mode. Okay, let's continue with case B. So let me erase this as we restart the problem. Okay, so we see for the EBJ, we have a base voltage of 0.8 volts and an emitter voltage of 0 volts. So this is a voltage difference of 0.8, which is greater than or equal to 0.7. So once again, our EBJ will be forward biased. Now for the CBJ, the base has 0.8 volts and the collector has 0.1 volts. So we have a voltage drop of 0.7 volts. So this will also be forward biased. And if you refer to our table, when both junctions are forward biased, we are operating in the saturation mode. Okay, now I'm just going to verbally solve through the following cases. So case 3, base to emitter is 0 to negative 0.7 volts. That's a voltage drop of 0.7 volts, so we are forward biased. Base to collector is a voltage drop of negative 1 volt, because we're having to go increase in voltage. So the CBJ is reverse biased. So we have a forward biased EBJ, a reverse biased CBJ. This is an active BJT. Okay, we have a base to emitter of 0.7 volts. That's forward biased. For the CBJ, we are going from 0 to negative 0.6 volts. That is a 0.6 voltage drop, which is not quite 0.7 volts. So this will be reverse biased. And once again, we are operating in the active mode. For case 5, we're going from 2 to 1.3 for the EBJ. That is 0.7 volts, which is a forward biased junction. And from the base to collector, we're going from 2 to 5. That's a voltage drop of negative 3. So this will be reverse biased. So once again, we're in the active mode. Okay, lastly, we're going from base to emitter. So we're going from 0 to 0, that's 0 volts. That will be a reverse bias junction. 0 to 5 is a voltage drop of -5 volts. So this will also be reverse biased. So if we have two reverse junctions where you're operating in cutoff, that solves the problem, but I will make one note that some textbooks, and just kind of depends on what your college professor defines, but some people will say that a forward biased junction only needs to be greater than or equal to 0 volts. So that would change the outcome of case C if we're following this principle. Then it would be the CBJ is actually forward biased. So case 4 would actually be saturation. So just make sure to check with your textbook that you're using, or just ask your professor how they've defined a forward biased junction. And that solves the problem. Thank you for watching this video. I hope you enjoyed it. If you have any questions or comments, please feel free to reach out to me in the comment section or by my email. Thank you and have a great day.